Okay, so we're on page 19. So suppose there are 2 blue, 3 green, and 5 yellow marbles in a bag. So one marble will be drawn from the bag. So we have 2 blues, 3 greens, and 5 yellow. So let's list the sample space for the experiment. Since we have 2 blues, we can write blues as B, and green as G, and yellow as Y. So since there are 2 blues, we're going to have 2 B's. And for greens, 3 greens, it's going to be 3 G's and 5 Y's for 5 yellows. So for the sample space, make sure you write them with the braces. And so it's 2, so B, B, G, 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 Y, 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 and Y. Okay, so those are the sample space for this experiment. And now we're going to calculate each probability. So where it says P with parentheses B, it means that's probability of you drawing a B, or blue. So in this case, there are 2 blues. Out of how many total? There's going to be 2, 3, so 2 plus 3 plus 5, which is 10 total marbles in this bag. So there are 2 blues, so you have 2 chances of you drawing a blue from the bag, which has 10 total possible outcomes. So it's going to be 2 over 10, which also you can write it as 0.2. This also can be written as a percentage. So you move the decimal place to the right twice, you get 20%. So just a reminder that probabilities can be expressed as a fraction, a decimal, and a percentage as well. So probability of G, of you rolling or drawing a green. So that there's 3 greens out of the 10 total marbles. So it's going to be 3 over 10. Okay. And for the yellow, we have 5 out of 10 total. So it's going to be 5 over 10. So it's half. So you have 50% chance of you drawing a yellow from this bag. That makes sense because you have 5. So 5, half of this bag is yellow. So when the probabilities of all the outcomes of an experiment are equal, then the outcomes are called equally likely. So are the outcomes in the marble experiment equally likely? So let's look at this. So we have 0.2, or 2 tenths, and 5 over 10, and 3 over 10. Notice how they're all different, right? The probabilities for each of them are different. That means they're not going to be equally likely, okay, because the number of each color marble is different. So because they had different numbers of different colored marbles, they didn't have 2 blues, 2 greens, and 2 yellows. It's 2 blues, 3 greens, and 5 yellows. So they're all different. So the probability must be different, and therefore we don't call them equally likely. Determine the sum of all the probabilities. So sum is, as you know, it's an answer to the addition problem. So probability of B plus G plus Y. So we have 2 tenths plus 5 tenths plus 3 tenths. When we do them, when we do that, we get 10 over 10, which is the same thing as 1. So notice how this is 1.0. So it's 1.0, but if you move your decimal place to the right twice, or just 1 times 100, because percentage is over 100, we get 100%. So 1 as a whole number is the same thing as 100%. That makes sense because we're trying to find the sum of all the probabilities. So probability of you drawing a blue plus you drawing a green plus you drawing a yellow, it's going to be 100%. Number 5, determine the sum of the probabilities for all the outcomes of the first spinner in activity 1.3. So this activity 1.3 we did yet last week. So we had 1, 2, 3, 5, and X and Z. So there were 6 total possible outcomes. So for the spinner to land on 1, there was 1 over 6 chance, plus another 1 over 6, plus another 1 over 6 for 3. 1 over 6, 1 over 6, and 1 over 6. So when you add them all up, you get 6 over 6, which is also equal to 1. That's also 100%. So do you think the sum of the probabilities for all outcomes of any experiment will always be 1? So the sum of all of the probabilities for all the outcomes of any experiment will always be 1? Yes, because 1 is equivalent to 100%, and all of the outcomes together make up 100% of the experiment.